Hello, and welcome to your Intro to Computer Science and Python lecture. So, computer science is everywhere, and that's more and more true every single day. So, you can think about what are the things in your life that happen because of computer science. And because of a lot of smart technology, things from your refrigerator to your cell phone to your electric toothbrush all use computer science. So I'll ask you this in class just as a bit of an icebreaker, but think a little bit about what your favorite use of computer science might be. Maybe it's the computer science that went into building your favorite video game. Maybe it's the fact that your car can do things that are smart. Maybe it's the fact that you can go on your phone and immediately reach thousands of people from different countries. In any case, think about it a little bit and we'll share some of them in class. All right, so in this class, we're going to be doing a lot of programming. So what is programming? Programming is basically just telling a computer what to do. For instance, we might give it some input, ask it to do some calculations, and then ask for an output back. Basically, programs are a set of instructions for a computer to tell it how to do something. Programming is also like learning to speak a new language. Just like when you're learning French or Spanish or Portuguese, you have to basically learn how to talk computer in order to program. Luckily, we have programming languages that will help us so that we don't have to write actual zeros and ones, but realistically, you should expect this class to sort of be like learning a new language. So we know what programming is, and in this class, we're going to be writing a lot of programs. So what makes a good program? Well, in my mind, it's these three things. The first thing is that your program works. This is the utmost important thing. If you need your program to do something and it can't do it, it's not a good program. So the first goal of any program we write is that it does what we want it to do. Next, we need to make sure that our program is readable by us. This means that when you are reading through the code that you wrote, you can easily understand what's happening. So in case you made a mistake or there's a bug or there's a change you need to make, you can easily tell what's going on and tweak it as needed. Lastly, someone else needs to be able to read your program as well. And this is not just for our class because I'm grading your code, but in general, because rarely are you going to write code that only you are going to read. So in addition to you being able to understand it, you also want other people to be able to understand it. And when you're writing programs, starting from the basic ones we write in this class all the way through your computer science career, you can kind of think of these as building on each other. First, we need to make sure that our program works. Then, once it works, we need to make sure that it's readable by us. And lastly, we need to make sure it's readable by someone else. So let's talk a little bit about computer languages. Like I said before, we no longer have to write computer code as a bunch of zeros and ones, which thank goodness. But there's a ton of different options for computer programming languages. You may have heard of some of them, like Java or C or any of the other C languages, Python, what we're using in this class, Ruby, Fortran, Julia, R, and there's tons more computer programming languages. There's even one called Shakespeare, which I've never used, but is basically a programming language that is made to look like a Shakespeare play. Variables are like actors, and comments are anything after a colon, like a line would be in a play. While I don't think you're going to make a career writing Shakespeare code, all of these other different languages are things that people use every day. So why do we use Python? Well, first let's go over a little bit of Python history. Python was created in the late 80s by Guido van Rossum, and it's named after Monty Python, which is a British comedy troupe. And that's why when you look through materials teaching Python, you'll often see weird references to the Ministry of Silly Walks, to Dead Parrots, or the Lumberjack song. People are constantly making Monty Python jokes because, of course, Python is named after Monty Python. One of my favorite things that ever happened on the internet was recently one of the members of Monty Python found out somehow, I don't really know, about the language Python and was just absolutely befuddled at it. He didn't really understand why Python was important, or especially how it could make money while being free. So a little bit of pop culture reference. I thought that was hilarious that one of the members of Monty Python got to, in some small way, appreciate the language that has kind of changed the world that was named after them. And you'll notice that we are using Python 3. Python 3 was created in 2008 and has pretty much taken over for Python 2, which until a few years ago was still a little bit more common, but pretty much anything you see nowadays is going to be written in Python 3, and that's what we'll use. So now that we know a little bit of Python history, why did we choose Python for this class? Well, there's a couple of reasons. One of them has to do with this picture on the screen. I mentioned before zeros and ones, and binary, or those zeros and ones, is basically how computers understand information. But people understand information using words. And so you basically have this scale from low-level languages, which are as close to zeros and ones as you can get, to high-level languages, which are as close to human language as you can get. And Python is relatively high on this scale. It sounds a lot more like human language than it does zeros and ones. And since most of you are probably new to computer programming, that's really valuable and makes it easier to learn. The next thing is white space. We'll talk more about this as we get into the basics of Python. But Python uses white space in order to determine which lines of code go with what. And that can be really helpful and a little easier on the eyes when you're reading it. Next is something called dynamic typing, which means that variables can change types, which will be useful as you'll see later. Python is also an interpreted language, which if you've ever dealt with a non-interpreted language, like something like C that you have to compile before you run, it means that when you write code, you can instantly run it line by line, which makes it really easy when you're learning and when you just want to test things out. Next, Python is open source. This means that it is free and you can use it however you want. And this is great because often when you learn things in university that are like paid programs or things you have to register for, you don't always keep that access once you graduate. But with Python, anyone can download it and use it. And that brings me to the next point. Python is free. And it's free in two ways. It's free as in beer, like you don't have to pay for it. And it's free as in speech, meaning you're allowed to do what you want with it. This means that people all over the world have created amazing applications and packages in Python that can be really useful to you. So hopefully, as we go through this course, you'll begin to appreciate Python and everything it does to make programming a lot easier for you. Another thing I just love about Python is the community. Like I said, people develop all kinds of packages and things that can help you do cool things in Python. But they also develop really silly things. So if you're ever in the position to do so, write a Python file that imports the package anti-gravity. And you do that by just typing import anti-gravity in a Python file and running it. I think it's very fun and you should try it when you have the time. Python is also great for new learners because it has the Zen of Python philosophy, that there should be one and preferably only one obvious way to do something. This is really helpful because it means that when you're learning Python, you don't have to learn 10 different possible ways of doing things. There's usually only one obvious and correct way to do things in Python. All right, let's talk a little bit about some computer science history. Before we had access to computers, people were computers. In fact, computing was largely seen to be a woman's job. And because of this, women often got to be some of the first programmers. If you ever want to dive any deeper into the history of computer science and technology, I highly recommend this book. It's not a part of this class, but it's something that I personally enjoyed when I read. And if this sort of thing interests you, I think it'll be right up your alley. It is quite well written and covers everything from Ada Lovelace all the way up to Bill Gates and Steve Jobs. So go ahead and check out this book if you think that sounds fun. So we know that back before computers were available, we had humans who were computers. Thankfully, we now have actual computers that help us do a lot of things. So let's talk a little bit about how computers, the non-human kind, work. Computers use something called transistors, which are basically like a switch that can turn on and off. So we know that in the past there were human computers, but finally we thankfully got computers. Computers use transistors to create ones and zeros by controlling the amount of voltage that passes through the transistor. And we can put a bunch of these transistors together in order to do pretty complicated operations. For instance, let's talk a little bit about logic gates. If we want something to light up or have electricity pass through it only if two other things are true, then we can use what's called an AND gate. An AND gate is going to basically only allow electricity to pass through if two separate things are both true. In other words, if this is true and if this is true, then electricity can flow through. The opposite would be an OR gate. You can see here that electricity can pass through this if either of these two things are down and connected, or if both of them are down and connected. If neither of them are true, then the electricity will stop here and won't be able to flow through. While these are pretty simple, this is basically how computers work with a bunch of these transistors and all of these operations. Computers work on the fetch execute or the fetch decode execute cycle, which basically means that when computers are computing things, first it has to fetch instructions, then it has to decode those instructions and figure out what to do. Then it needs to execute those instructions, and then if there is any, it needs to output and store whatever came out of those computations. In order to do all of those things, the computer needs a bunch of different components. Processors are basically the parts of computers that actually do your computations, like a CPU or a GPU. We also have some type of main memory, like your random access memory that you are currently working with and is active when using your computer. Next, we have permanent memory in the form usually of a disk drive or a solid-state drive. We also have inputs and outputs. This is basically anything that can either give out or take out information from your computer. For example, your screen is an output device. It shows you output from your computer, whereas a keyboard, a mouse, or a touchpad are all input devices. It helps you tell the computer information. And last but not least, unless you're on the world's most boring computer, you probably have a network. Networks are a way of computers talking to each other, and it can be everything from a LAN connection when you or your friend are playing video games with your two computers in the same room to a network like the internet. All of these parts come together to help a computer do all of its computations. Now, remember before, I said that computers actually speak in zeros and ones. And it's amazing what kind of complicated information we can represent with just a bunch of zeros and ones. And one of the ways that we can do that is with something called binary. Binary is a way of representing numbers with just zeros and ones. And the way we do that is kind of like the way we use regular numbers. Binary is base 2, whereas our number system is base 10. So in our number system, we have a ones place, right? Like the number 101 has a 1 in the ones place. The 1 tells us there's a 1 there. In binary, though, we go by 2s. So we have a 1s place, and then a 2s place, and then a 4, 8, 16, etc. all the way up. You can see each of these places represents 2 to the power of 0, 1, 2, 3, 4, etc. To read binary numbers, you basically take whatever place it is and add them all up. So for instance, the binary number 110001111 is basically saying there's 11, 12, 14, 164, and 1128. This means to get what this number is, we would add 128 plus 64, none of these because they're all zeros, 14, 12, and 11. When we do that, we get that this number is 199. And you might be thinking, well, that's quite silly. Why would I ever use that? But binary can be really useful. I found this really fun example on TikTok where someone found a fan that uses binary in order to indicate how many hours the fan should run for. Now, if you had a fan like this, where you only had room for 4 little display light buttons, well, what would you do? The simple thing to do would just be to give people 4 options. Maybe it can run for 1 hour, 2 hours, 5 hours, or 10 hours. But that really doesn't give people a lot of control over exactly how long they want their fan to be on. This fan actually uses binary, and you might recognize that by the places that they have. It has 1 place, a 2 place, a 4 place, and an 8 place. And the way that this fan works is every time you click the timer button, it adds an hour, and it does that using binary. I'm going to go ahead and insert this full clip so you can kind of see what I'm talking about. But as you are watching it, pay attention to how efficient this is when they only had 4 display lights to give people as much control as possible over the number of hours their fan was going to run for.
I don't know if I'm clever enough to have come up with this counting system for the timer. If you said, here's 4 LEDs and you have to count time up on it, I probably just said like 1 through 4. But very clever. It's every time you push it, it just adds 1 hour to it using these 4 numbers. So it's 1 hour, 2, and then you add an hour, making it 3. And then you go to 4, and you add another hour, make it 5, and 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. With 4 LEDs, they can get you 15 hours of variability for the time. That's programmer type thinking right there. I do not have the brain for that. A million years, I don't think I would have come up with this.
And binary can be used to represent all sorts of complicated information, from images to sound waves. All of it can be represented with just 1s and 0s, and I think that's pretty cool. All right, so we've been talking very generally about computers and programming. Let's talk a little bit about Python specifically. One of the things we want to learn how to do with Python first is how to give output and get input. So let's go to VS Code in order to see how that's done. All right, so here we have a pretty much empty Python file with just a few comments. Let's talk a little bit about output. The simplest form of output we can have in a Python program is a print statement. A print statement basically tells Python what to output. So let's write a print statement. I'm going to say the word print, parentheses, and then open quotations and say hello world. Then I'm going to save my program. You can tell it's unsaved because of that white dot. And then I'm going to go ahead and run it so we can see the output that the Python program gave us. I'm going to go to terminal, new terminal. And as always, just make sure this is in the right folder that my file is in. It is, so we'll go ahead and move on. To run the Python program, I'm going to type in the terminal, Python. And then if you're on a Mac, you're going to need to add 3 because Macs come with Python 2 and 3, so you have to specify. Otherwise, you can just write the word Python. And then the name of the file I want to run. The name of the file is up here. It's intro to CS1 blank, there we go, .py. When I hit enter, this is going to run all of the code in our program. For now, it's just going to give us our output because there's only one thing, the print statement, in our file. So let's go ahead and run, and you can see that the output of our program was the string hello world because we asked Python to output or print the string to the console for us. Next, let's talk a little bit about how to get user input. Obviously, I'm inputting things into a file by typing them, but what I mean here is when our Python program is running, how do we get input from a user? Well, one way we can do that is by using the input function. I'm going to create a variable called name, and I'm going to use the equal sign to set it equal to input, parentheses, and then inside I'm going to put a question. You can think of the input function as asking a question, and then it'll wait for the user to type in a response via the keyboard. So let's say, what is your name? And then I'm going to put a question mark. By the way, you don't need to do this. I usually add an extra space at the end of my strings when I have an input function because it looks a little prettier, which you'll see in a second. All right, so the computer is going to ask for user input, and then let's do something with that. So before we printed the output of hello world, but let's print a little bit more of a complicated output. Let's print the output of hello space, but then we'll print name. So instead of name, there we go, if I spell it correctly. So instead of saying hello world, this program is going to say hello and then whatever the person's name is, because that's what they entered. All right, let's go ahead and save and run. So you can see we have our hello world output, and then we have this output of what is your name, which is the question that our input function is asking the user. And you can see that nothing else has happened and this little cursor has appeared. That's because the program is waiting for our input. So here I'm going to say Chelsea just by typing it and then hit enter to say that you're done. You can see that when I put in Chelsea as my name, it returned the output hello Chelsea because we asked it for an input and then used it to print an output. All right, let's do one more input example. So here I'm going to ask for someone's age, and I'm going to do that by creating a variable called age, setting it equal to, and then saying input, we'll say how old are you? And then we'll print you are plus age plus years, we'll put a space there, years old. All right, let's go ahead and run that. We'll say Python 3, intro to CS blank. And you can see what is your name. My name is Chelsea. How old are you? Well, I am 74. And it says you are 74 years old because we asked it for an input and then we used it to produce an output. Next, let's talk about errors. You're going to get a lot of errors in this class, and that's okay. Honestly, half the battle of being a good programmer is being able to quickly figure out where errors are coming from and how to fix them. So I want to talk a little bit about a couple of common types of errors you might see. All right, let's talk a little bit about value errors. Value errors occur when you give an inappropriate value to Python. For instance, let's look at this function, the float function. The float function takes something like a string and turns it into a floating point number, which basically just means a number with a decimal. So I could easily do something like 123.1 and say, okay, I have this string, it's in quotes, I want to turn this into a number. So I'm going to save and I'm going to run, and Chelsea 74. You can see that our program ran with no errors. In fact, I'm going to comment this out so it doesn't run every time. But you can see that this ran with no errors. But what if instead of using 123.1, which is a decimal number, what if we use the string hello, which doesn't really have an obvious way of being converted into a float, which is a number with a decimal. So let's see what happens when I run this. Oh, we got an error. Okay, what type of error did we get? A value error. It says here it could not convert the string to float, and then it gives you the string that gave it the problem. Here it's hello. This is basically Python's way of saying, look, you asked me to convert this to a decimal, but I have no idea how to do that. It'll return a value error to you. You can see that Python is pretty useful at giving you some information about what's causing the error. First, here you can see what the value is that caused the error. In this case, it's the string hello. And second of all, it'll tell you where in your file and which line the error came from. Now, as we write more complicated programs, these error messages get a little less helpful, but still, anytime you see an error message, this is the first thing you should look for. All right, let's comment that out. And then let's talk about type errors. Types are different kinds of objects that you can have in Python, which we'll learn a little bit more about later. For instance, two of the types that we have are a string, which basically you can see contains words or characters, and another type we have is like a number. So let's say ABC minus 10. All right, so this is basically asking Python, take the string ABC and subtract 10. Let's see what Python has to say about that. Oh, we got another error, and this time we got a type error. This says unsupported operand, which just means an operation, types for the minus operator. It says string and int. So this is saying you tried to do the operation minus, and you tried to do it with an object that is a string and an object that is an integer. And Python doesn't know how to handle that, so it gave you a type error because the type of these two things is wrong. If we change the string to be another integer, let's say 15, we wouldn't get this error anymore because two integers can do a subtraction operation together. When you get a type error, it means that usually one of the things you're working with, like a variable, probably isn't the type you think it is. All right, next let's talk about a name error. Let me just give you an example before explaining what this is. I'm going to take a variable x and I'm going to set it equal to a variable y. Let's go ahead and save this and run. Yet another error, and you can see this time it's a name error. The name error basically is saying that the variable name that you're using doesn't exist yet. You haven't created it. In this case, I'm trying to set a new variable x equal to the value y, but nowhere in my program, you can see as I scroll up, did I ever define a y. So the computer is basically saying, I don't know what y is. So if you ever get a name error, go ahead and look and see if the value here, y, is something that you've used before or created in your program. You probably haven't if you're getting a type of error like this. All right, last but not least, let's talk about syntax errors. Syntax errors are very common, especially when you're first learning Python. Let's try and do something. I'm going to check if two numbers are equal. So I'm going to say 1 and I'm going to say double equals, but oops, I accidentally put a third equals, and then the number 1. Let's go ahead and save and run and see what Python has to say about this. Okay, we got another error. This time it's a syntax error. Syntax errors are very general, and they basically mean that the way you wrote your Python code is doing something incorrect. In this case, when I want to check if two things are equal, I use two equal signs, which we'll talk about later. When I run this with the appropriate number of equal signs, you can see that my program runs no problem. Anytime we get a syntax error, it means that Python can't even tell what we are trying to do. There's something wrong with the way that we've written our code. Just like with the other errors, it's actually pretty good at telling us which lines and even where it thinks the error is. And so if you ever get a syntax error, this should be the first thing that you're looking at to see where it thinks the error is. By the way, the first thing you should ever look for, just from personal experience, if you get a syntax error, is are you missing parentheses or colons or something like that? All right, so those are the 4 main types of errors I wanted to go over. You'll get lots more types of errors. Don't worry, there's no shortage of errors in this class, but those are the 4 main ones that I want to go over that you might see as you start to type some code. All right, last but not least, let's talk about IDEs, or integrated development environments. IDEs are basically things that help you write code. For instance, VS Code is an IDE that we're using. Other options are things like Atom or Idle or anything you've used like RStudio. Basically anything that's sort of like a fancy text editor that helps you write your code is an IDE. The one that we're going to be using, as I mentioned before, is VS Code. And if you haven't already downloaded it, make sure you do now. All right, that's all I have for you. I will see you next time.